We're going to talk about 5.5, completing the square. This is going to be a 2-day thing. Today is going to be the foundation. Tomorrow we add an extra component to it. So we really need to make sure that we are getting this foundation right now. So first thing we're going to do is just determine what is needed to replace C to complete the square. What it means by that is you're looking for a square trinomial. Okay, so we're trying to make it a trinomial that if you were to factor it, you would get something like x plus 2 and x plus 2. That's where the whole square aspect comes from, because it would be able to be written as x plus 2 squared. So you're trying to rewrite this original trinomial as something that could be factored like that, okay? So the big thing that you do here is b divided by 2 squared, okay? And we're not going to write that every time, but for now, that's just the main focus of today. Okay, so b divided by 2 squared. So for this first one, b is 18. It's just like what we do before. So 18 divided by 2 squared is what c is going to be. Well, 18 divided by 2 is 9, and 9 squared is 81. So 81 would be what completes the square. Now, I do want you to show your work like this right now because it makes more sense later when we do it. So keep that in mind. On number 2, b is negative 14. And if you divide negative 14 by 2, you get negative 7. Negative 7 squared is a positive 49. Remember, whenever you square a negative, it becomes a positive. Last one over here, divided by 2, b divided by 2, which you cannot reduce, right? So because it's not something that can give me a solid number, what we're going to do is square both. So 15 squared is 25, 2 squared is 4. All right, so this time you're going to find c, and then you're going to rewrite it as a perfect square. Okay, so when we do that, we're going to do the same process. B divided by 2 squared, or 2 squared, which is 4. Okay, so I'm going to put the 4 there. That's part of my answer. The other part is if you were to factor this, which you could every time, but if you were to factor it, you would pretty much get this. The only thing is you have an x part of it. So it's x plus 2 squared. Okay, so that is rewriting it as a perfect square binomial. On the next one, negative 8 divided by 2 is negative 4 squared, which is a positive 16. And then again, we rewrite it as minus 4 squared. You can get rid of this step, and I'll show you in a second. You don't have to write all of this out. It makes sense for you to write it that way. And then for the process that I was just showing you, that's totally fine. So number 5, similar to the first number 3. Apparently, I fixed the numbering here. You can't reduce it. So all you do is square it like normal. You would end up getting 25, because negative 5 squared is 25, over 4. And then because I don't have that extra parenthesis, I just use this one. So x minus 5 halves squared. Okay, so let's talk about solving by completing the square. The first thing you're going to do is to look like number 5, or the second number 3, or number 4. Okay? You want to see your variable squared minus your variable plus a blank. Okay, but we need a blank on both sides. So let's put blanks in here. Okay, we want it to look like, obviously the 16 needs to move over, so we're going to add. Then we're going to put a blank over here, because the golden rule of algebra is that you do to one side, you have to do to the other, right? So if I start to this the way that we were just before, negative 4 divided by 2 squared. The negative 4 divided by 2 is 2, for a negative 2. Negative squared is a positive 4. So I put in one blank, I need to put in the other blank. So just like above, we are going to rewrite this. We factor it. It would become x minus 2 squared. Remember, it always matches that. And that's equals 60 plus 4, which is 64. At this point, we just need to solve for x. To cancel a squared, I would square root. So we're left with x minus 2 equals 8, but do not forget plus or minus. Okay? It could be positive or negative 8. So the last step is to split it into two equations, where we have x minus 2 equals 8 and x minus 2 equals negative 8. So over here, if you add 2, you get 10. Over here, if you add 2, you get negative. So following that process in number 7, first thing we have to do is multiply. So r squared plus 6r plus 6 equals, subtract the 8, we get 1. This time I'm going to do this without showing this middle stuff, okay? So if I divide 6 by 2, I get, so I'm going to put it like this, okay? So you divide it by 2 and you rewrite it as binomial. And then all you have to do is square that number. So notice that it's 3 squared. So 3 squared is 9, and I need to put it in both. And it's going to equal negative 11 because negative 20 plus 9 is negative 11. Oh, sorry, this should probably be an R. It really doesn't matter. I'm not, but you should stay consistent. Okay, so at this point, we're doing the square root, right? So we have R plus 3 equals the square root of negative 11, right? Well, first off, if you have a square root, it's plus or minus. And if you notice, there's a negative. Whenever there's a negative underneath the square root, we pop an eye out. And 11 is 5, so we can leave it like that. Now we're almost done. But I'm going to subtract 3 over, which if you notice, obviously that can't be combined with our root 11. So we just kind of tack on the front. So we have negative 3 plus or minus I root 11. When it's something like this where you can't actually solve like you can over here, you just leave it. Don't try to give me two answers. At this point, I encourage you to pause the video and try these on your own before you continue. So go ahead and do that right now, and then I'll go through them. Hopefully now you've had enough time to go through each of these problems, and we can figure out them right. So we have n squared plus 8n plus 1 equals positive 48 plus 9. If you do d divided by 2, you get n plus 4 squared. And if you square 4, you get 16. Right? If you add 48 and 16, you end up getting 64. Now we would square root. N plus 4 equals plus or minus 8. So we can split it into two equations. N plus 4 equals 8, and n plus 4 equals negative 8. On the left, n would equal positive 4. On the right, n would equal negative 4. On number 9, start off the same way. We have our blanks in. We have a blank on the left. We would add 1 to the other side, we get 2, and then we need a blank. At this point, 3 divided by 2 gives me negative 1. So n minus 1 squared. Well, negative 1 squared is 1. We put it in both blanks, which means it equals 3. Now we would take the square root. So n minus 1 equals minus the square root of 3. Notice how we did not pop an I out because it is positive. At this point, 1 to the other side, and you're left with n equals 1 plus or minus the square root.